The hollow Earth. It's an incredibly compelling idea. But is it real? What does actual science tell us about the deep structure beneath our feet? To get a clear understanding, we must look at the confirmed model, the crust, the mantle, and the core. All dense and solid layers. The hollow Earth concept has existed for centuries. From early scientific thinkers to famous fictional and folklore narratives, this hypothesis was largely dismissed, especially once we developed our most critical tool, seismology. The study of waves. Seismology uses earthquake waves to scan the planet's interior. Much like a doctor performing an ultrasound on a body, shear waves, S-waves, cannot travel through liquid. And they are completely blocked by the Earth's liquid outer core. If the Earth were hollow, these waves would travel dramatically differently. Completely unlike what our instruments actually record, hollow models often suggest an inner sun. But there is no known physical mechanism to explain how such a star could form inside. In fact, the Earth's magnetic field is one of the strongest physical proofs that directly refutes the hollow concept. The magnetic field is generated by the churning motion of liquid iron and nickel in the outer core. A hollow sphere simply cannot do that. A hollow Earth would have a very different gravitational pull. It couldn't sustain an atmosphere or attract matter as it does now. If the interior were hollow, the distribution of its mass would make the Earth rotate and wobble very differently. The deepest human drilling projects have only scratched the crust, which is merely a thin skin compared to the entire planet. Even the compass pointing north relies on the giant dynamo created by the super-hot liquid motion in the outer core. Density data clearly shows that the interior core must be incredibly dense and heavy, far denser than the surface rock. Every earthquake recorded globally provides precise data on the speed of wave transmission through the internal materials. These speeds perfectly match the characteristics of super-dense solid and liquid materials. Not a hollow void is theorized. Modern science proves that the mantle beneath us is a thick, dense mass of hot rock, not an empty volume of air. Active volcanic eruptions are physical evidence of molten magma sourced from the deep mantle, not from some hidden inner world. The Earth's formation process through differentiation resulted in a dense, layered structure, with heavy materials sinking to the center, peridotite. The dominant rock of the mantle can only exist under the extreme pressure and heat of a solid, compressed body. The Earth's total mass is accurately calculated, and a hollow sphere would simply be far too light to match the measured value. If the Earth were hollow, seismic waves would pass through the center at a very different speed. This does not happen. The stunning phenomenon of the aurora borealis is a reminder that we are protected by an active and dense core-generated field. Scientists use diamond anvil cells to mimic core pressure, confirming that inner materials are in a super-dense solid and liquid state. The Earth's measured moment of inertia proves that the mass is heavily concentrated towards the center, not just the outer shell. It is only because the Earth is solid and dense that tectonic plates can float on the viscous mantle and form our continents. Huge meteorite impact craters don't puncture the crust. They only create vibrations that travel through the solid core. Analysis of retrieved rock cores shows increasing density and temperature, consistent with a solid Earth model. The idea of an inner sun makes for great fiction, but it violates all known laws of physics regarding energy and gravity. The deeper you go, the temperature and pressure increase exponentially. This can only happen in a solid, compressed object. Even the deepest caves we explore are only a tiny scratch on the tens of kilometers thick outer crust. The Moon's gravitational pull on Earth is also evidence of the cohesive mass and solid density of the entire planet. The convection of the liquid in the outer core acts like a gigantic electrical generator, sustaining life on the surface. The oceanic crust is much thinner, but even beneath it, we hit a dense mantle layer almost immediately. If the Earth were hollow, its average density would be much lower. Unable to reach the measured value of, in 51 cents, text, gram per centimeter, carat $3, the inner core is a solid ball of iron, compressed by pressure 3 million times greater than the surface. But let's not forget, it was Jules Verne and other authors who popularized the hollow Earth idea into a classic science fiction tale. Seismograph stations in remote locations like Antarctica are constantly collecting data to confirm the inner structure, comparing sizes, The inner core seems small, but it is the densest, heaviest part. Definitely not an empty space. Inertia calculations have cemented the evidence. The Earth must have an extremely dense center to spin the way it does. Today's supercomputers continuously run complex models to better understand the dynamics of the solid core. The intense heat and pressure forced deep drilling projects to stop, having only penetrated a tiny fraction of the crust. The Moho discontinuity, where the crust meets the mantle, is clear evidence of dense material layering. Ultimately, the solid, layered Earth, shaped by physics and evidence, is far more fascinating than any fictional theory.